I built this Midi harmonica a couple of years ago, and I wanted to improve upon it because it would take a U-Haul truck to move it around. Because it used the piano from the player piano for suction and a 220 volt air compressor for blowing. So I have decided to try to build a portable Midi harmonica that could be moved around. And this is my video log from the beginning of the project. And I'm trying to build this thing from parts from around my house.
Carousel. To create a lung, such as this. So here's a box with a closes. Right over a little bit. But the problem is that I tried to put a stepper motor to this, and it's not strong enough. And stepper motor, you would know the position. The other problem is if you had to blow in two different notes, you'd have to also then turn the air off. So you'd have to go on, somehow pull it away, and back on. So one thing's clear, it has to be much bigger than this. So here's a sort of proof of concept I built. Again, the motor's right here. The problem is that when this thing comes down, it has to go back up. Whereas if you're going to blow, now the next note was a blow, I have to open up something here so it can go very quickly and blow, or draw, go down very quickly, because otherwise, when it's going up, it's going to do a different note than when it's going down. So I have to be able to go back up. So bottom line is I need one going in, one coming out at the same time. So if this one's going out, another one over here going in. So try that next. So I'm learning 100 ways how not to do this. This too has a problem. And here, as this one goes out, it's creating suction on the inside, and on the other side, it's pushing in, which is creating pressure. Now, the way it works, this is a piece of rubber or a leather strap. So as this pulls out, it allows the air to come freely out of here, which creates vacuum into this hole, so that as this comes out, it's letting the air out, and then when it goes back in, it can't go this way, so it comes out this one on the outside. So as it opens up, it comes out here, and then pressure here. But again, next time, all of a sudden this one's drawing air, so now it's the suction side. Next time it's the pressure side, suction side. So you're always having to keep track of where the location is and whether or not you have two valves, having to open up one or open up the other and keep track, because halfway around it changes, so you'd have to have a cam to know exactly where, whether it's drawing or sucking, as this thing is turning back and forth. This isn't the right idea either. All right, this one here is 3 of them. Goes up, one side goes down, and the other side goes up. and then there's rockers across the top. So as this one here is going up, and then on top there's two holes, a hole in one and there's a hole in the other. So the rocker goes up. So this one here, the hole's blocked and it's pushing in. Now all of a sudden the hole's not blocked, but now this hole's blocked and it's pushing in, pressure. Now back over here, hole's blocked, pushing in. Now you go the opposite direction, the hole's blocked, it's pulling out, hole's blocked, it's pulling out. So one direction, it pumps, in the other direction. Okay, from the top view. Now the air is coming out there, and it's coming around to our harmonica sitting right there. During one direction, other direction. Harmonica. That looks really good. Now on top, that foil is because it's made out of wood, the clearances weren't real tight, so that is aluminum tape that's making the clearances a little bit better for me. Right, now, this wheel back here is off of I think a pool sweep pump. It's the little wheel that for the self-cleaning wheel that goes down the bottom of the pool. It was in my garage. Matter of fact, everything's in the garage. This rail that's going back and forth is a drawer slider hinge. This motor is off of a water pump motor. There's another motor down below. It's off of a cordless drill. The brackets are from a table saw that no longer worked. And there is I'm going to see if I can zoom in here. We'll zoom in. Now there's a potentiometer that's sitting in here. So here's a bigger view of it. And that turns, that whole rail goes down, and now it's to the one harmonica that's on there now, but you can put multiple harmonicas on the same rail. The potentiometer, so that it'll know exactly where it's located. And then we'll go out more. Move. It then rotates. So this thing turns, the motor turns, and it moves the wheel. And there's a belt right here, This belt right here goes to this potentiometer. Here's my finger. Now, this is 2 P channel and 2 N channel MOSFET. What it does is create to reverse a motor. And I'll diagram it out in a second. Over to the side is an optocoupler right there, and those are basically a light from the little computer board turns on, which then switches on, pulls those to ground, so they're held high. And then over there are a couple of relays. There's 2 motors. One motor runs the air, and one of them moves the rail back and forth. Now, on this show, though, a lot of people don't understand the concept, even of what has to be done. To make the motor go in reverse, you have to reverse the wires. Well, physically, that's easy to do, but electronically, there's a couple ways to do it. Now the roller, or the slider, is hooked up to the relays, and they're a little slow. When I hit them, so that's the relay, and you have to put delays in there to give it enough time for the relay to attach a knot. So I'm going to go to the Moffats. I want to use the other one actually so I could use velocity, but I'm going to switch. Now I've hooked up the motor to go back and forth and the pump. I got a lot of working with the code, including calibrating the holes. This is a test to see if we're at least in the ballpark. I switched the pins to the Moffats on instead of the relays so that I could use analog right instead of digital right. Digital right is just on and off. Analog right is, if you do analog right 255, which is always on, analog right 0 is always off, and in the middle 150 is half on, half off. Now it's not half the amount of voltage, but it's in time. So it's on, off, half the time, or always on. Now the potentiometer measures between 0 and 100 or 1054 or something like that in terms of voltage. Not technically voltage, it's 5 volts, but that number. And so as the potentiometer changes, it goes all the way to the, turning it all the way down would be 0, and all the way up would be 154, and then there's a range somewhere in between. So what I did is I measured what that number is for each hole on the harmonica. And so if the hole is further away than 20 from where the potentiometer is now, I'm analog writing half speed. And if it is closer than 20 away, I'm analog writing, actually I'm analog writing a little bit less than that. I'll get particulars, so we're going to try it now, first time. So it currently is somewhere in the middle. And that works. I could speed it up a little bit, I could slow it down, but as it gets within 20, it slows down a little bit now, so it gets to that correct pitch. I'll show it again in a different direction.